Hello everyone, welcome to today's class. This is Teacher Simon taking you through ASPO Mathematics 1, paper 9701/11 for May, June 2022, and this is part 1 for questions 1 to 6. Question 1 part A, express x squared minus 8x plus 11 in the form x plus p bracket squared, then plus q, where p and q are constants. Now this is what we call completing squares. I'm going to show you two approaches. You pick one which is simpler for you. The first one, before I even go there, when we have, let's say, x plus b squared, this identity here, then we shall have x squared here, then plus 2bx plus b squared. Then you can have a side with only x's here, so I can take this on this side. Then we have x plus b squared, then minus b squared, which will be equal to x squared plus 2bx. Now from here, we can see a b here and also a b here, okay? Now, these ones are coming from, but when you look at the right side here, it is 2b here, the coefficient of x. So this coefficient of x, 2b, when it is divided by 2, you are getting this b. Now, this b can be put inside here and also here. By the way, the sign that is here matters. If it's a minus, then even here we shall have a minus. But always here we are having a minus. Why? Because when this one crosses the equal signs, it becomes a minus, right? Okay, so that means when we are completing squares here, I'm going to have x squared minus 8x, then plus the 11. So the first thing we do is to make sure that the coefficient of x squared is a 1. If it's not a 1, we first factorize, but this one was already given as a 1. Now we go to the coefficient of x, we divide it by 2, we shall get negative 4. So we shall have x, then minus 4, okay, squared, then minus 4 here, squared, plus the 11, just like we have here, okay? So suppose maybe this one was a minus. Let me just change it such that it looks exactly like what we are having here. So it is x minus b. You get the x, you square it, you get the x squared. Then 2 times x times minus b, then you get minus 2bx. And then square the minus b here, you get the plus. You see that? So when you bring this on this side, still, because it is a positive, it becomes a what? A minus. Okay? So that is that. So I just get this one divided by 2. I put it together with the x here in the brackets, and then I pop it out as a square. You see? The rest is to simplify. So x minus 4 squared, this will be minus 16, then plus what? 11. So meaning we shall have x minus 4 brackets squared minus 16 plus 11, that will be a minus 5. So this means that p is this negative 4 and then q is negative 5. You see? So because here we're having a plus and a plus here, it doesn't mean that you must have a plus here and then a plus here. No. P and Q are constants. They can be positives or negatives. So alternatively, you can also do it this way. You can expand and then equate coefficients. So x squared minus 8x here, then plus 11 will be the same as x plus p here, then squared, and then plus q. So when we open here, we shall have x squared, then plus 2px, then plus p squared, then now there is this plus p, and then of course this one is equal to this other one here. Now we can equate coefficients. So the coefficient of x squared here is 1. Even here it is 1. We leave that. The coefficient of x here is negative 8, but then this side we are seeing 2p. So we equate that to 2p. Then when we divide all through by 2, then p becomes negative what? 4. And then also the constant part, what are we seeing? We are seeing 11 then is equal to, the constant part here is p squared plus q. That means q is going to be equal to 11 minus p, which is negative 4, square it. This will be 11 minus 16, and then the q becomes negative what? 5. Okay, so meaning that our x squared minus 8x plus 11 then is the same as, now you substitute in here where there is p, you put a minus 4. And then where there is q, you put a minus 5. Isn't it the same thing as this? So that is that. Then part B, hence, this one means begin from where you have stopped. Find exact solutions of this. Now, for you, if you bring this one here, then you have the plus 10, and then you solve that quadratic equation, maybe using the bulldozer or the quadratic formula, you are going to be crossed because they said hence. But if they say hence or otherwise, then you can use any other method to solve. Okay, that is the otherwise. So this one here is this. So I will just say x minus 4 bracket squared, then minus 5, then shall be equal to 1. Take this one this side, it adds to 1, so we shall have a 6. That is x minus 4, then squared, which is equal to 6. Then we shall take square roots on both sides. We shall have x now minus 4, which is equal to plus or minus the square root of what? 6. Then when I take this one this other side, that means x is going to be equal to 4, then plus or minus root of 6. And this becomes my answer. So one x value is 4, then plus root of 6. The other one is 4 minus root of 6. But you can leave it like that, 4 plus or minus root of 6. Question 2. The 13th term of an AP is 12. That means we are having a, then plus. Remember, the nth term of an AP is a plus n minus 1d. So if we say 13th, so put 13 here minus 1, you get 12, not so. So we shall have a plus 12d, then we equate to 12. And then the sum of the first 30 terms, sum of the first n terms of an AP is given by n over 2 into 2a, then plus n minus 1d. Okay, so if we have sum of the first 30 terms, that means n is 30, so we shall have 30 over 2, then into, we don't know the first term, then 30 minus 1, that will be 29, you see, then we equate this one to negative 15. So this will be a 15 here, 15 into 2a plus 29, then this one will be equal to negative 15. We can divide all through by 15, so meaning we shall have 29, pardon me here, I've been forgetting a d. Okay, let me put it there. So 29 d here, then we close d, we close, and then here when we divide all through by 15, we shall get 29, then plus 2a plus 29d, which is equal to negative 1. So this is one equation, and this is another one here. Okay, so now we solve the two, solving 1 and 2 simultaneously. What do we get? Okay, now we can use which method? You can use elimination, you can use substitution. So from here, actually a can be equal to 12, then minus 12d, not so? 12 minus 12d. Let me make this one my equation 1. You see? So when I do so, I can be in position to substitute. Okay? So let me substitute now. Equation 1 into equation 2. So we shall have 2, then a is going to be what? Is 12 minus 12d, then plus, this is 29d, this one is equal to negative. Then this will be 24, then minus 24d, then plus 29d, this one will be equal to negative 1. 29 minus 24, that is 25. That would be a 5, not so. So if this is a 5d, and then take this one this other side, it is negative 1 minus 24. So that is negative 25. So d will be negative 25 here. Then we divide by 5, and then d becomes negative 5. Now, what is our a? Our a is 12, then minus 12d, which d is negative 5. Now here we shall have 12, then plus 12 times 5, that will be 60. So meaning our A here is going to be what? 72, right? And then sum of the first 50 terms that they want us to find is going to be 50, okay? We shall have 50 out of 2, then into 2A. Our A is 72, then plus 50 minus 1, that will be 49, then times D, which is minus 5, you see? And then after that, altogether, what do we get? 50 over 2, that one will be 25. Then inside here, we are having 2 times 72, that is 144. Then plus, we have, in fact, I can say minus 5 into 49. And then we get minus 2525. 2525. Question 3, the coefficient of x power 4 in the expansion of this one is a, then the coefficient of x squared in the expansion of this one is b. But find a and b in terms of k. Now, when we are expanding using the binomial expansion, if we have a plus b then to the power of n, we shall get n, then combination something here, which will be of course a 0, then a power n, then b power, this will be power 0. So a begins with this power, and then b begins with this power 0, and then the power of the b is the one that goes into the combination. So plus, then n combination 1, then a power n minus 1. So a loses a power, and then b picks that power. So it continues on, and then until when we get n combination n, then a is to the power of 0, and then b is to the power of then n. So this one happens, we get this one here for, we call them finite series. Okay, those are the ones that end. So that is when n is a positive integer. And this one, they bring it in paper 1, but in papers 3, they can give you a fraction. If n is a fraction, that one doesn't end. Or if it's a negative whole number, you see? So n has to be a positive integer for this one to end, okay? The one you do in paper 1. Now, so what happens is that for the first one here, the first term begins with the power of 5, then 4, 3, 2, 1, 0. Then the second one, this part here, k squared over x, begins from the power of 0, then 1, 2, 3, 4, and then 5. And when you look at the sum of all of these powers, actually they give us this 5 that is given here. You see that? Now, here they are referring to the term in x power 4. So the coefficient of x power 4 in this expansion is a. I'm not going to expand each and everything here. I'm just going to pick out the term in x power 4. So for this one here, 2x squared, then plus k squared over x, then to the power of 5, you can say term in x power 4. This one is going to be, I'm going to put first of all the 5, then combination something, then I'm going to have 2x squared here, and then you take this term here, that is now our a, and then this is our b, right? Then we shall have k squared out of x, and then power something here. Now, I need to pick a pair, okay? If I put 5 and 0, this will be power 10. And of course, this one disappears. Then, remember, I have to end in power what? Power 4. Then there is 4 and 1. So when you put 4 here and 1 here, you will have x power 8. Then divide by x, that will be x power 7. Okay? Then when I pick 3 and 2, so when I pick 3 and then a 2 here, that means I will have 6 here. You see that? And then x power 6, then divide by x power 2. This one will end in x power 4. So that means I'm supposed to pick 3 and what? 3 and 2. So put a 3 here, put a 2 here, then this 2 here is the one that I'm going to put down here in the combination. So 5 combination 2, this one is going to be 5 times 4, 20 divided by 2, that will be 10. then times 2 cubed, that will be 8, and then here x power 6, then we shall have k power 4, then over x squared. So altogether we shall get 80, then k power 4, and then this is now going to be the coefficient of x power what? 4. Okay, so this simply implies that our a here, which is the coefficient of x power 4, will be 80, then k power 4. As simple as that. Then we go to this other one here, 2k x, then minus 1. It is to the power of 4. Now here we are going to move from 4, then 3, 2, 1, 0, then 0 here, 1, 2, 3, 4. Okay, so here we need to get the term. Okay, we need to get the term in what they said, coefficient of x squared. So the term in x squared, we shall have 4 combination something, then we have 2kx here, and then we have a negative 1. Please always take this sign together with that term. If you don't, you will get wrong things. Now, since we don't have an x here, and we have to end in x power 2, so automatically I will put a 2 here. That means this one will also be 2, such that when I add, I get the 4. So that means the one that I'm picking, the pair, is 2 and 2. Then the power that is here is the one that comes into the combination here. So 4 combination 2, that will be 4 times 3. That is 6 divided by 2. 4 times 3, that is 12 divided by 2. We get a 6 here. Then times 2 squared is a 4. Then times this will be k squared, then x squared. And then 1 squared is a positive 1. Even power of a negative is a negative. Is a positive. Now here we shall have 24k squared, which now happens to be the coefficient of what? X squared. So meaning, right from what we are given, that b is equal to this 24k squared, because they said that b is the coefficient of x squared. So that is that. Then part B, given that a plus b is equal to 216, find the possible values of k. What is our a? Our a, we got 80k power 4. So 80k power 4. Then plus our b is 24k squared. So 24k squared. Then this one is equal to 216. That means I can bring this on this side. And then we have the 24k squared here, then minus the 216, which is equal to 0. This is a quadratic equation. This is a quadratic in k squared. Okay. All right. Now, can this one be simplified? Of course, we know 80 can be divided by 8. Then 24 can be divided by 8. You get a 3. And then 216 divided by 8. What do we get? This one gives us 27. So I will have 10k power 4, then plus 3 k squared, then minus the 27 here, which is equal to 10. I can use my calculator to simplify this one, to factorize it. We go to mod, then equation is option 5, and then quadratic is option 3. Then the coefficient of this k power 4. Remember, by the way, this one is, I said it is a quadratic in k squared. So it is k squared here, then squared, then plus 3 k squared, then minus the 27. You see? So if you want, you can let your y maybe to be equal to the k squared. Then you have 10y squared, then plus 3y minus the 27. You see that it is a quadratic equation. Okay. So now, right from here, we can put this one in the calculator. So our a is 10, then the b is 3, and then the c is going to be negative 27. So we get 3 over 2, and then negative 9 over 5. Negative 9 over 5, and then the 3 over 2. Now, I have skipped space here because I have to show the examiner the attempt to solve the quadratic equation. If you just write this in the exam, you go. Okay, so this is how to cheat the examiner. You cross multiply here. You give us the factors from which these roots come. Okay, so when I cross multiply, I'll get 5k squared, right? 5k squared, and then bring this minus 9 here, so it becomes a positive. That is the factor from which we get this answer. And then from here, when you cross multiply, you will have 2k squared, and then bring the 3, it will be a minus 3 here, like that. And of course, in the real system, we cannot get the square root of this negative here. So this one here is undefined. Okay, here we are having a complex number. Okay, but then here, our k then is going to be plus or minus the square root of 3 over 2. And that will be our answer here. Question 4 is coming from trigonometry part A. We are supposed to prove this identity that it is equal to that. Okay, remember when we are proving identities, you can begin from the left side to prove the right side, or you begin from the right side to prove the left side. But it is always, in most cases, it is always hard to prove from the right side because it requires some little bit of thinking. Okay, so let's begin from the left side. It is always easier to begin with the left side. So sine cubed theta, then minus, here we're having sine squared theta, and then this one is sine theta minus 1, then 1 plus sine of theta. So here, I'm going to get the common denominator. I'll multiply these two, then multiply this one here, and also that one there. Okay, so by doing so, our denominator here is going to be sine of theta minus 1. And then here we shall also have 1 plus sine of theta. Now, here, by the way, I can see sine cubed and sine squared. So what is common here is sine squared, but I can first leave it. Okay, so this is sine cubed theta into 1 plus, then sine of theta, and then minus, this is going to be sine squared of theta, then times sine theta minus 1. Okay, then when we open, this is actually a difference of two squares. I can switch these ones here, and then I have sine theta, then plus 1. Okay, but maybe let's go slow. Let's open the brackets. We are going to have sine cubed theta, then plus sine here, power 4 of theta, minus, this will be sine cubed of theta, then plus sine squared theta. And then down here, we are going to have sine of theta, then again sine of theta times that, so it will be sine squared theta, then minus 1, then minus sine theta, minus sine of theta. Now here, this one will go with this, then again this one will go with this. Okay, then from there, that simply implies that up here we are having sine to the power of 4 of theta, and then plus sine squared of theta. And then down here, we are having sine squared theta minus 1. Okay, but when we look at what we are having here, tan squared theta is the same as sine squared theta over cos squared theta. So first, I will pull out the sine squared from here, sine squared theta. So meaning inside here, I'll have sine squared theta, then plus a 1. Now, do you see that I've already gotten this one? Okay, then next down here, I must have a cos squared theta, but using the Pythagorean identity, cos squared theta is equal to 1 minus sine squared what? Theta. So how can I get 1 minus sine squared theta from the denominator? I will pull out a negative 1. So when I pull out a negative 1, then I will have the negative now becomes a positive. So that will be 1. Then the positive becomes a negative. So it will be 1 minus sine squared of theta. When you multiply all through, you come back to this. You see that? Now, from here, we shall have this sine squared of theta into sine squared theta plus 1. Then out of, what shall we have here? Cos squared theta. So it is minus, then cos squared theta. So sine over cosine is a tan. So that means we shall have negative, then tan squared theta into 1 plus sine squared theta. And this is exactly what they wanted us to find. Then part B, hence solve the equation, this one here. Now we know that this part here is equal to this one here, right? Negative tan squared theta. So we shall write negative tan squared theta into 1 plus sine squared theta, okay? Then this one is equal to tan squared theta into 1 minus sine squared theta. And then from here, we can see the tan squared theta dying, you see? Or you put everything on one side, okay? You put everything on one side, because by doing so, we are killing a solution, you see? So take this one to this other side. We shall have tan squared theta into 1 minus sine squared theta. When this one crosses, we shall have a plus, okay? Then tan squared theta into 1 plus sine squared theta. And then from there, we equate this one to what? To 0. Now, tan squared theta is common, so I pull it out. Then here I remain with 1 minus sine squared theta. And then here I have, what do we have? 1 plus sine squared theta. Not so? Now from here, we shall equate this one to 0. Now, inside here, you can see that this one goes, and then here we remain with the 2. So we have 2 tan squared theta, which is equal to 0. Now, suppose you had cubed this and this, because you are seeing it is common on both sides, you would have negative 1 plus sine squared theta, okay, which is equal to 1 minus sine squared theta. When you open the brackets, negative 1, then minus sine squared theta, which is equal to 1 minus sine squared theta. Now, do you see that this one is common on both sides? So when you try to rearrange, that one goes. Now, you are having negative 1 is equal to 1. What is that? So you are not going to have a solution here. So therefore, when you are solving equations, don't kill these expressions here, okay? We kill them when we are simplifying, let's say, expressions like in the proofs we had, okay? Now, so this one has to, you have to be very careful with this. Never kill a solution by killing out this and this. No, just put things on the same side, and then when you do so, you factorize out what is common, and then you proceed, okay? So if we had killed, then we wouldn't get the solution here. But by putting everything on one side, you have seen that we actually remain with the tan. Now from here, I can divide all through by 2, and then I take the square root. So that means our tan is going to be equal to 0. Then theta is going to be equal to the arctan of 0. Then this one can be 0 degrees. Then we have 180. So that is what? Pi. And then 360, which is 2 pi. So that means our theta is going to be pi based on what we are having here. So that is that. Question 5 is coming from circular measure. We are seeing this diagram here, which shows a sector ABC of a circle with center A and radius R. Okay. Now that means this one is also R up to there. If this is the sector, so this one here has to be equal to that because they have the same arc. Okay. Now, what else do we have here? We are saying the line BD is perpendicular to AC, angle CAB is theta in radians. Now, before you do anything else in circular measure, you turn your calculator to what? To radians, okay? Given that theta is equal to pi over 6, find the exact area of BCD in terms of R. So BCD here, we have to get area of this sector, then minus area of this triangle. Are we there? But then for area of this triangle, since it is right angled, then we can use SOHCAHTOA first of all to get the BD. Okay? Now, how do we get the BD? Relative to this angle, this is the opposite side, right? This is the hypotenuse. So we can use sine to get the BD. Then, relative to this angle here, this is the hypotenuse, and then this is the adjacent. That means we can get this AD using the cosine. Are we there? Okay, let's begin. So using SOHCAHTOA, remember for any right angled triangle, you are expected to use SOHCAHTOA or Pythagoras what? Theorem. So using SOHCAHTOA, we can have sine of theta is equal to the opposite, which is BD, then divide by the hypotenuse R. So meaning BD is going to be equal to R sine of what? Theta. And then also cosine of theta is going to be equal to adjacent, which is AD, then out of the hypotenuse, which is R. So meaning AD is going to be R, then the cosine of theta. So if we are getting area of BCD, this one is going to be equal to area of triangle ABD, then minus, no, actually it has to be area of the sector, so then minus area of the triangle ABD. So let me take this one away. So we shall say area of sector, because it is the bigger one, sector ABC, then minus area of triangle ABD. So this one has to be D here. And then from there, area of the sector is a half R squared. So our R, of course, it is R squared. Then the theta is pi over 6. And how we get this here, if we have a circle and this is the sector here, we have R and R, then it forms an angle here. So this is what we call a sector here. So this sector, area of the sector is going to be equal to theta, then out of 360, that is if the theta is in degrees, then times this sector here takes a portion of a circle, and area of the circle is pi R squared. But in radians, this 360 is equal to 2 pi. You see that? Then we have pi here, then R squared. So meaning this one will go, and then you'll have a half, then theta, then R squared. So that's why we have a half R squared, then the theta. Okay, so here theta is in what? Radians. You see that? So that's why we're using this one here. So if you are using this one, your calculator has to be in radians. But if you use this one, the calculator has to be in degrees. You see that? Okay, then minus area of the triangle ABD. This one is a half times the AD. AD here is R cos theta. So R, then cos of pi over 6. Then times the height here BD, which is actually what? R sine theta. So times R, then sine of pi over 6. You see that? Then we simplify this one. This one is going to be pi out of 12, then R squared. And then here minus R times R. That is R squared. So we shall have R squared here over 2, then times cos of 30 is root 3 over 2. Then sine of 30 is a half. So that means we shall have pi over 12 here, R squared. Then minus, this will be R squared. It will be root of 3 over 8, then R squared. And that will be that. Then part B, given instead that the length of BD is root 3 over 2 of R. Find the exact perimeter of BCD in terms of R. So length BD. Now BD, right from here, we got it as R sine theta, right? So when we say this BD, which is r sine of theta. So we shall say r sine of theta then is equal to root of 3 over 2 of r. Automatically the r will go. That means sine theta then shall be equal to root 3 over 2. So theta will be equal to the arcsine of root 3 over 2. Okay, arcsine of root 3 over 2 is actually 60 degrees, which is the same as pi over 3. You see that? Now they want the perimeter. So when you check back here, the perimeter of BCD, perimeter will look at sum of lengths around the shape. So we need BD, which is given. We need the arc BC, and we also need the DC here. Okay, now let's go back. Perimeter here is going to be equal to, so perimeter of BCD is going to be equal to that BD, then plus the arc length of BC, and then plus, what else do we have? CD. Now, how do we get the CD? CD here will be this one here, the R, then minus the AD, okay? Which AD, we have it here as R cos theta, right? So we shall have our BD, it is given as root of 3 over 2 of R, then arc length here, we know it as r theta, but it comes from this arc here subtends an angle at the center here, which is theta, then out of course, the circumference, the angles at a point add up to 360 degrees. So divide by 360 degrees times an arc is part of the circumference of a circle. So we multiply by the formula for the circumference of the circle, which is 2 pi r. But in radians, if theta is in radians here, so we shall have theta, then 360 in radians is 2 pi, then times the 2 pi r, then this one disappears, and then we shall have r theta. So we shall get the radius here, then times the theta, which theta we have gotten as pi over 3. Are we there? Then plus our CD. CD right from here, it will be SC, which SC is r. Okay, so it will be r, then minus, we shall get this AD, which AD is r cos theta. So we shall write r, then cos of the angle we have gotten here, that. So simplifying this will be root of 3 over 2 of r, then plus pi over 3 of r, and then plus r here, then minus cos of 60 is a half. So we have a half of r. So r minus a half of r, we shall get a half of r, not so. So this is root of 3 over 2 of r, then plus pi over 3 of r, then plus a half of r. And this becomes our answer. If you want, you can factorize out the r. Then question 6 is coming from functions. The function f is defined as follows. For x greater than 2, find an expression for the inverse. Now, if the inverse of a function is equal to, let's say, y, I can take the f this side. That means I can have x, which is equal to f of y. That is the same thing as saying interchanging x and y, right? So that means where there is x in here, I will put the y, okay? So I will have now y squared minus 4 out of y squared plus 4. So what we are left with is to get the y. We make y the subject of the formula. So when we cross multiply, we get xy squared, then plus 4x. Then this one is equal to y squared minus the 4. And then from there, I can put everything onto one side. So maybe I can put terms that have gotten y onto one side, and then x, I also put them onto one side. Maybe I can bring this 4 to come this side, and then I take this one this other side, okay? So when I bring this one here, and then I take this one this side, I'll have 4x here, then plus 4. then which will be equal to y squared, then minus xy squared. Then we factorize, put out y squared, it is common, then we shall have 1 minus what? X. Then this one is going to be equal to 4x, then plus the 4. And then when we divide all through by this, that means our y squared is going to be equal to 4x, then plus 4, then out of 1 minus x. But we are not interested in y squared, we are interested in the square root. So y is therefore going to be equal to plus or minus, because you know when you take the square root, you have plus or minus, right? That is that. But then when we are writing our inverse of the function f inverse, we are going to choose one sign here. So this one is going to be the square root of 4x plus 4, then out of 1 minus x. So when you reach here, you don't need to waste time. You just look at the sign which is used here for the domain. This is greater than 2. So if it is greater than 2, then we choose the plus sign. If they had used less than, then that means we use the minus sign. So for that case, we are having the plus sign there. Then part B, show that this one can be expressed in this format and hence find the range of f. Now 1 minus 8 out of x squared plus 4. This one, if this one is over 1, then the LCM is going to be, or the common denominator, we just multiply these two, right? And then we shall have this x squared plus 4. Then multiply it by this one here, so you have x squared plus 4, and then 1 times negative 8, we shall have minus 8. So meaning we shall have x squared, then minus 4, because 4 minus 8 is minus 4, right? Then out of x squared plus 4. So this one is already done. Then they are saying hence state the range. Now remember the domain we were given is this one here, greater than 2, x greater than 2. So that means whatever I'm going to have here, this thing is all going to be positive. That means we are subtracting something from this one here. Every value that we are going to get, we shall be subtracting something from the one here. So that means whatever we are going to get is going to be less than what? 1. So the value of f of x is going to be decreasing, less than 1. But this whole thing cannot be 0, because this one will never be a 1. I think it can be a 1. Yes, it can be a 1. It can be a 1 if this one is 2. Because if I have 1, then minus 8 out of 2 squared plus 4. So 4 plus 4, 8. Then this one will be what? 8 over 8, which is 1. So 1 minus 1, you get a 0. But remember, they told us that x is greater than 2. So that means we are beginning from 2 point something, whatever. You get it? So that means what we are getting here, the range of f is going to be f of x, first of all, is less than 1. Okay, it is going to be less than 1. Okay, this one here has to be greater than 0, because when you are subtracting something from here, this fraction here is a proper fraction. So 1 minus a proper fraction, it cannot be bigger than 1, right? Hey, if you have 1 minus maybe 8 out of 9, you get 1 over 9. You see that? All right, now this happens to be our range. But now if you put f of x, let's say less than 1, okay, less than 1, that means there is a possibility of getting negatives, and yet this one cannot be a negative, because you are getting 1 minus something small. Whatever you're going to get here is going to be smaller than 1, so there is no way you can get a negative. So we have to say it is above what? Then part C, explain why the composite function f cannot be formed. Now when we are forming the composite function, if we have two functions, we have a set of values here. I want to show you something small here. A set of values of x here, then f acts on it. So what comes out is what we call the f of x. So this is the domain. A set of values of x we put, or a set of values we put in the function is what we call the domain. So this is domain of f. And then the set of the output is the set of the outputs is what we call the range. So this will be the range of f. Then we again bring f here. F acts on this result. Then you get f of x. You see that? So that means the range of f now is going to be the domain. For this new movement, we are going to have domain of f here. Then here we get the range. This will be the range of f of x. Okay, ff. Now, that one is the one that takes this one to this side, ff. Now, explain why the composite function cannot be formed. For the composite function to be formed, if I have f of x, in fact, let me use two different functions. If I have f, then g of x. So since I'm putting this g of x in f, that means this g of x must fit into the domain of the function, because remember, what we put in the function is the domain. But you are having g here, what comes out is the range of that g. Are we there? Now, the range of the g must fit into the domain of the f here to have the composite here. You see that? But now, when we look at these two here, what is the range? Range of f, we have seen it is 0 less than f of x, then less than what? 1. And then we also have the domain. What is the domain of f? Now I'm looking at this part here, okay? The domain of f here. So domain of f is actually x, then greater than what? 2. So from 2 and above. But this one here, the range of the f for the first one here is actually before the x is equal to 2. So that means this one here doesn't actually fit in here. In other words, it is outside of this. So I can just say that the range of f, which is 0 less than f of x, okay, is outside the domain of f. That's the domain of f, which is x greater than what? 2. So you cannot compose the f into itself. You see that? So that is that.